People here, not everybody. So I hope everybody can hear me okay. She said she can, so that's good. All right, this is INF 160. This is called Networking Essentials. This has never been taught online before. It was always taught in person in front of a class. So we're all in uncharted waters. Let's hope we can do this as well as we can. I miss the camaraderie you get where we can chat back and forth. It's going to be very difficult for us to talk to each other. I wish you wouldn't unmute your microphones, because if you did that, there's a lot of background noise. It doesn't mean you can't ask a question, but I noticed something. There's a chat button on the bottom. You could ask a question with the chat, except when I'm in the PowerPoint mode and I'm lecturing, I really can't see the chats. So it's going to be very difficult for us to interface and talk back and forth, which I think is a problem, but I don't know what I can do about it. All right. So what I'm going to do now is this. Okay, now can everybody see these PowerPoints? You should be seeing the PowerPoint. Yes. Okay.
Yes.
Now this is just an intro lecture I'm going to do, and you probably see me down the thing, and there's only 4 of them. And then the real part of it is there'll be 20, 30, 40 regular PowerPoints, and I'm going to basically narrate them. So that's how the course is going to go. Again, I can't write on a whiteboard because I don't have one in back of me. I can't do all my dynamic stuff running around the class because I can't do it. This is all I can do. I hope that it works. I'm not sure if it will. Let me put it another way before I start this part of it. The motivated people who really came to college to learn and who are going to actually do the readings and who are going to actually do the questions at the end of the chapter and are actually going to try to underline the stuff, I think you'll get through this course fine. There's always a few people in college who came here to sort of do the minimum they can, sit in class and daydream, not do any assignments. You may have trouble. Again, I would be able to get you guys through if I was in person with you. It's going to be harder to do it this way. So this is going to reward the hardworking students who actually do the reading. This is not a hard course, but I'm about to explain with these PowerPoints why you're taking the course. First of all, I'm Professor Gary Correa. Nice to meet you all. Good, everybody. And there's a reason you're taking the course that you may not realize. So this is my favorite thing I'm going to do. And I'm just going to ramble, and I don't normally do this, but I think you'll get a lot out of this. So let's see if I can go to the second slide. Good. All right. So we're having a recession. In the 1930s, they had the original recession called the Great Depression. Now, I know you're going to raise your hands. This isn't a history class. Why do you care about that? Well, if you wanted a job in 1935 and you were hard-pressed to get one, you were competing with a whole bunch of other people in factory jobs because the factories were all over the place. And you wanted to be the guy in the factory job. So the way it worked was, if you use an Acme tool and die machine or a Strahan tool and die machine, if you could go to the company that made it, you could get certified that you were good at using that tool and die machine, you might get a job when other people couldn't. So an industry certification is a certification by a company that says you can use our machine and you're certified to use it, got you a job when nobody else could get one. Now, admittedly, in the 1930s, these were all blue-collar jobs, but you were starving. You wanted a blue-collar job at $20, $30, $40 a week, and you were lucky to get one. So there were such a thing as industry certifications, but they mainly prepared you for, as I said, blue-collar jobs. Even I wasn't born then. Now, flash forward to the 1990s, when I was born. In the 1990s, they had what were called Novell certifications. And what this was is Novell had invented the whole thing of what a network is. What you know of a network today and how the internet works now and how the network works, Novell really invented the local area network that is sitting in a room with a server and a bunch of computers attached to it. And it was a fairly complex system, and nobody understood it. So Novell said, look, we'll give special exams and we'll certify people. And if you get a Novell certification, they were very difficult exams. And by the way, the reason I'm good at this, I taught those exams way back then. We'll get you a job. And it wasn't a blue-collar job. It was a $70,000, $80,000, $90,000 a year job, which in the 1990s was really high pay, even higher today. So for the first time, you could get an industry-wide certification by a corporation and actually get a fairly decent white-collar, high-paying job. Well, everybody said, well, I want to get these. And in fact, people did get them. And in fact, they really did get high-paying jobs. Now, the bad news is Novell has sort of gone down the drain. The stock market has crashed and everything has changed a lot. Well, who has replaced Novell? Actually, I'm going to do this in a minute, but the 800-pound gorilla that's replaced Novell is, of course, Microsoft, and we'll talk about them in a minute. Now, you may not have heard of a company called CompTIA, but CompTIA has certifications, and the CompTIA certifications are A+, Network Plus, and Security Plus. Each one of those is a separate test. Each one of those is a separate certification. But if you get any one of those, or God forbid, get all three of them, people will hire you at a decent paying job, 40, 50, 60,000, which is not super high, but it's not, you're not sweeping the streets and you're not flipping burgers. So how would you get these certs? Well, the normal way to get them is you have to go to a special training school on Route 4, Route 17, and you'd go to this training school for 1 or 2 weeks, and you'd pay them about $2,000. And you'd sit through an intense thing and write a lot of stuff down. And when you were done, you would sit for the test. And if you studied hard, you might get one of these tests and get a job. A+ came out first. That's the one that says you're certified to repair computers. Okay, people said, okay, repairing computers is a good entry-level job. I want a little more money. Can you help me out? Well, the Network Plus certification, that's the one that lets you troubleshoot and build entry-level networks. And of course, that was the standard one for a long time. And then finally, Security Plus came out, and that's network security because it's so important. Now, to get this training, again, would cost you $2,000 or $3,000 at a trade school. Well, Bergen Community decided, look, if you want the A+ certification, if you take Bill Madden's course, INF 108 PC Repair, it's not an official training course, but it covers the same material. So if you complete Professor Madden's course, you might be able to, should be able to, could be able to get the CompTIA certification. And it's pretty good. Well, that's all they had for a while. So the next one, the middle one on the slide is the big one. Network Plus came along later, and that would be, I'm certified to be not a true network administrator, but an entry-level network administrator. I can work on networks, okay? And that pays even more. Well, normally you go to a trade school on Route 4, Route 17, pay them about $2,000, and you would take this course and hopefully pass the test. Well, look what it says there. INF 160, right? Which is this class. If you're taking INF 160, we're going to cover, just coincidentally, the material for Network Plus. That's what we're going to do in 15 weeks here, okay? So I'll go to the next one in a minute. But my big thing is you may think you're here because you have to pass this course to graduate from Bergen, and that's probably true. If you're in the network AASIT degree, you have to get this course because they won't let you out, and that's also true. But for a few of you who are more intelligent than normal and better looking than normal and brighter than normal, you might want to also get this certification. Now, the way you do it is you have to go pass the test when you're done. That means you have to do, when everybody else is going on Christmas break, you have to go and do extra study. If you're willing to do that extra studying and you get that test passed, it might qualify you for an entry-level job. And that's why you might want to see that this course is a little bit more valuable than you thought to begin with. I'm talking mainly to the people who want to slide through the course with the minimum grade, just get a C, and just get me out of their hair. You can certainly do that. I would think that the smarter ones of you would want to get an A in this course and then try to go for this. Because it will. By the way, you won't get any extra credit from me if you do it. The only thing it will help you do is get a better job. That's why you're doing it. Let me just talk about the last one for a minute. As you know, internet security and security and hacking and cracking are a big deal. We have a certificate in security and all kinds of stuff. CompTIA put on the Security Plus cert. This was the third one they developed. And it turns out you'd have to take another special course on Route 4, Route 17 to get that. But if you take the INF 267 course at Bergen that we teach here, called Network Security, you could or should be able to get that. Get any one of these and you will get a job. Get any two of them and I guarantee you'll get a job. But get all three of them and you'll be in really big demand. So for those of you who are here in college to not do the minimum work, who are here to actually learn something, you might want to spend extra time and extra energy doing all this, going for all these certifications. And again, right now, we're all concentrating on this one because that's where we are. And so that's really why you're here. Now, again, this little lecture, for those of you who are still arriving late, this has nothing to do with the course. This won't be on any test. I'm just trying to motivate you. Okay? Next slide. We talked about Novell in the 1990s inventing networking. Novell then hit the skids and went, they're still around, but the stock is way down. They don't do much. The 800-pound gorilla took their place. What's the 800-pound gorilla? It is Microsoft, okay? And Microsoft has a Windows Server. Now, when I say Windows Server 2XX certification, what I mean is it's called Windows Server 2016, 2012. Now I think it's either 2018 or 2020. It's the latest one. And it's a test, and it's a very difficult test. It's a very difficult test. If you take our INF 252, the Windows Server class, and by the way, I don't teach that. We have an adjunct who teaches. He's very good. You could or might get a Microsoft cert. The previous slide. If you take these three, I guarantee you'll get a job. If you take this one, you get a higher paying job. It's much harder test, much harder certification, but now you're Microsoft certified. And unfortunately, Microsoft has a whole bunch of tests, and I wish we taught more of them. This is the only one we cover here. No reason why you can't get training and take other Microsoft tests if you want to. We just don't do it here. Okay. That would be a really good one to take. And again, it's nothing to do with this semester. But if you stick around and don't flunk out and stay here, and you get to the second semester and you take this with, I think, Professor Perez or Caruso, whoever teaches it, you could get this test passed. So it's very difficult. Okay, we're almost there. We're not going to start the course. But there's a few geniuses sitting there say, Professor, this is very interesting, but I want to make a lot of money. I want to have money coming in like this and that. I want real bucks. Can you help me out? I got a plan for you too. This guy, Cisco makes routers. And what is so great about routers? Well, the internet runs on routers. So when you say you're router certified, it really means you're internet certified. The internet is nothing but thousands of routers all over the entire world. Now, this is the most difficult test of all of them, but it also pays the most money. We have a course called INF 265 Network Configuration. The problem is it only teaches the first half of Cisco, because this consists of two tests. Nevertheless, anything you get in Cisco, one test, two tests, anything, is going to look very impressive on a resume. Okay? So if you want to make really big bucks, you would have to bust your chops and try to do this. But if you do it, you'll be paid very handsomely. Now, let me just do this one more time. You take any one of these three, and you'll probably get some kind of entry-level job. You take any two of these three, and I guarantee you'll get some kind of job, and you won't be flipping pizza. You take this one, and you'll get a much better job. Okay? You take this one, and they'll be pouring money down your shorts. All right? So if you really want to make some money, this is the one to take. Now, again, they go in order. The first three I told you are not easy, but they're doable. Microsoft is much, much harder. Cisco is ridiculously hard, much harder, but they'll pay you the most for it. So what I'm trying to do here is separate the what's the word? Separate the energized people or the motivated people from the people who are just here because they have to be in college. You're paying money to go to Bergen. It's pretty cheap, but you're still paying money. You might as well get the most out of it. And I agree that an education is a good thing to have just to get an education. But I think that you really want to get an education to get a job. And if you're going to get a job, I think you're going to want to get a high-paying job if you can. Anyway, that's my thing. Right? Morales, I just saw you. I can't see the chats when I'm doing this, but anyway, you can get these certifications. You would have to sign up for them, and you would have to go get them. It's not part of the Bergen thing. We don't give them to you, and we don't, give them here. You have to go out and do it on your own. And again, I won't give you any extra credit. You can't do this instead of taking the final. You have to take my class. The only person this is going to help is you, not me. Okay, so I was going to say I don't care if you get them. I wish the best for my students, so I hope you do get them. But those who want to get them should think of doing it. And again, that's the reason why you might want to pay close attention in this class, and why you might want to try to get a high grade, and why you might want to learn as much material as you can and not try to learn the minimum. That's just my input. Okay. Okay, I'm going to see now what I can do here. I've stopped sharing. If anybody has any questions, there's two ways they can ask a question. You can do the chat thing, or you can even unmute your microphone and ask a question. I can't have really class discussions because there's like 30 people in the class. And if we had a class discussion, it would go all over the place. You see what I mean? But if you send me a chat, I'll try to answer it. And you can unmute to ask a question. Just stay muted if you're not asking a question. All right. Now, you probably want to know about the course. Gee, I have to get this right. So what I should do now next is share the, I should talk about the, I'm still learning how this works. I hope I'll get better at this, but I'm still learning how this works. Ah, there it is. Yeah, but I don't know. Oh, okay, I can't do it that way. All right, well, I won't share it then. I don't know how to do it. I think I know how to do it. I think I have to go to documents and bring it up and then. Anyway, didn't I send everybody a syllabus, an outline? I think I did. When I sent the email, I sent you all an outline. And let me just see if I can do something here. So we can talk about that if I can get it up, but if I can't, we'll talk about it anyway. All right, I can't do it. I'm sorry, I can't do it. If you look at the outline that I gave you, and you don't have to open it now, I'm just going to talk. I'll learn how to do this better as I do it a while. The textbook is whoever the gentleman who asked me at the beginning. It's the Tom Show book called Network Essentials, and it's called the 7th edition. Now, be very careful about the 7th and 8th edition. The 8th edition is the latest one, okay? It's extremely expensive. It's $125. And since it's brand new, you got to pay for it, and that's it. The 7th edition is one back. It's not a bad book. And because it's been out for a good 6, 7, 8 years, you should be able to pick it up used very cheaply. So try to get the textbook, the one I have listed on the thing. Try to get the 7th edition. and try to get it used. When I say pretty cheaply, I'm talking about 10, 20, 30 bucks, right? And the reason we want the 7th edition is several reasons. The PowerPoints we're about to go through support the 7th edition. And with the questions at the end of the chapter, the 7th edition is better supported. Is it slightly out of date? It's a little old, but it's not really terribly old. So get that book if you can, and don't worry about getting it by tomorrow. If you have to find it online, they have to mail it to you, and you get it a week from now, it's no problem. Our first test isn't coming up until the end of September, early October, and so that shouldn't be too bad. Having said that, though, even though it's not in front of me, hopefully it's in front of some of you, we're doing a chapter a week. Now, here's the cuidado, big cuidado, listen up. 1 week is 2 class meetings. So we meet Monday, Wednesday. Today's Wednesday. If this was normal, we'd meet Monday, Wednesday, Monday, Wednesday, Monday, Wednesday. Because we're starting on a Wednesday. The first week is Wednesday, Monday. The second week is Wednesday, Monday. The third week is Wednesday, Monday. So today and next Monday, I will somehow try to fill up chapter 1. Now, you may get bored with me. Oh, chapter 1, all day, chapter 1. Yeah. But when I'm done with chapter 1 and I go to next Wednesday, then I'm going to chapter 2. Next Wednesday, next Monday is chapter 2. And there'll be a lot of PowerPoints. Hopefully you'll take notes. Hopefully you'll learn stuff. The following Wednesday, following Monday is chapter 3. Following Wednesday, following Monday is chapter 4. We're going to go right through. Okay? So we'll go through that way, a chapter a week. We'll always be stuck with Wednesday, Monday because we started on a Wednesday. All right? And I wish I was showing in front of you. So try to get the book, which is the one I showed you, the 7th edition. Again, it's a big hint, but try to get it used. A lot of people say, I said, you know how to work the internet. Oh, yeah, I've been using the internet for years. Do you know how to go to search for used books and used textbooks and how to search the sites? If you can do that, you might get the book for 10, 20, 30 bucks. You might even get it for $5 or $10. Okay? I don't care if it's all beaten up. I don't care if it's a piece of garbage. If you can read it and understand it, that's all I care about. So get the book as soon as you can through the internet. Try to buy it used. Make sure it's the 7th edition. And I've given you the ISBN number and all that. And have it as soon as you can. We won't have homework. The only thing we'll do on some of the chapters, we'll try to do the questions at the end of the chapter as a review. And that's how we'll try to do it. Okay? All right, so that's where we are. I don't know how well this is turning out. I'm hoping that you're all highly motivated because you all want to get those certifications. I'm going to try to cover the same material I cover in the in-person one. In other words, I'm going to try to cover everything. Because we're lecturing this way and because it's online and because it's this way, I might leave a few things out. There's a special lecture I give at the end that I hope I can give you anyway. It's going to have to reorganize it. But we're going to try to do everything we would have done. This is not my favorite way to teach. I don't think it's a good way, but as some of you people said when I met earlier, we're stuck with this, and I think we can make it work the best we can. Okay? I'm just pausing. If anybody has any questions, you can either unmute and ask me or send a chat, anything, and I'll answer it. But it's pretty straightforward, okay? Oh, I know there's one other question. How do you get a grade? Okay. We're going to have 4 exams. And normally the 4 exams, you sit in class with me, and they're written exams, and you do a Scantron sheet, and A is B and C is D, and you do that. Because I can't do it that way, we're going to have to take the exams on Moodle. Now, Moodle is not open yet, but this week or this weekend, by next Monday, Moodle should be open. And your exam isn't coming up until, I think, the end of September, early October. I don't give surprise quizzes. I don't give surprise exams. So you'll know when the exam is. I'll announce it well in advance. And here's the biggie. I will give a formal review for the exam. I will give a formal exam review so you'll know exactly what's on the exam. I won't tell you the answer to question A is so-and-so, the answer to question 2 is so-and-so, but I'll say there will be a question on this topic. There will be a question on this topic. There will be a question on this topic. So you'll know all the topics that are going to be on the exams and what you have to study. And I'll even give you page numbers to study. So there'll be 4 exams. Okay? online on Moodle. And the exam is generally the time of the class, but because we're doing this class this way, I'll give you, let's say the exam would be on a Wednesday afternoon at 3:15. You'll have from Wednesday at noon till Thursday at noon to take the exam. So you won't take it during class. You'll take it before or after class. But you won't be able to take it 2 weeks later. So if I say the exam is Wednesday at 3:15, it means you could take it Wednesday at noon, 1, 2 o'clock. You can take it Wednesday 8, 9, or 10 in the night, or you can take it Thursday morning at 8 or 9 or 10. So I'll give you like a 24-hour or 12-hour period to take it. But people are coming 3 weeks later. I want to take the first exam. It's not letting me. Well, yeah, because the first exam was 3 weeks ago, not now. So anyway, 4 exams. Okay. And I haven't decided. We used to do a term paper project. I don't think so because of the way we're doing this. I haven't decided on that. I'm probably not going to do it because this is going to be a real pain in the neck for all of us. Having said that it's going to be a pain in the neck for all of us, I still maintain, though, you can learn this way. And the way you're going to learn is you're going to listen to my lectures. You're going to get the, oh, by the way, when you do get into Moodle at the end of the week or next week, I'm going to give a lecture in a few minutes starting today with PowerPoint. The PowerPoint I'm using, I'm not going to download today because it's too complicated. That will be in Moodle. So when you get to Moodle, download the first 3 PowerPoints. Why the first 3 PowerPoints? Well, week 1 is chapter 1, week 2 is chapter 2, and week 3 is chapter 3. At the end of that time, there'll be an exam on chapter 1, 2, and 3. You know what I mean? So you're going to want to download those 3, learn them cold, be ready to take an exam on those again in about 3 or 4 weeks. The second exam will come just before Halloween. So when you're trick-or-treating for Halloween, you will have taken 2 exams. The third exam will come just before Thanksgiving. So when you're stuffing yourself with a turkey on Thanksgiving, you will have taken 3 exams. And the 4th exam will come just before the Christmas break. So there'll be a pre-Halloween exam, a pre-Thanksgiving exam, and a pre-Christmas exam, and 1 exam, I think either the first week of October or the end of September, I don't know when. But it will be announced well in advance. You'll know when it is. Okay? That's your exams. I see no questions, so I'm going to start the course in a minute. Okay, everybody seems to be okay. Again, you could send me a chat and just say, what is so-and-so? Or you could unmute and ask me. And you can always talk about this as the course goes on. Okay, so if there's the bad news and the good news is lecturing like this is useless. I mean, this is garbage. So what I have to do is, they're PowerPoints, and the PowerPoints are from the book. That is, the book publisher gave me the PowerPoints. If I was lecturing to you in class, I would have the PowerPoints up on a thing, and how can I say it? They're really to prompt me. In other words, I know this material, but I forgot what I should say. So the PowerPoint says, look, now cover this topic. Look, now cover this topic. Look, now cover this. So the PowerPoints prompt me to lecture. I probably will not, an invite to Moodle. When I open Moodle, you are in INF 160. I think this is the 002 class. So when Moodle gets opened, and by the time we meet next time, it will be open and you can fire me if I haven't. Just go onto Moodle, look for INF 160 002, and you should be able to get on if you're an official person in this class, which you are. Right? And if there's any problem, we'll straighten it out on Monday. Yes, you have a question? Somebody? Anybody?
Yeah, I was gonna say that I know it's gonna be difficult to interact while you're speaking, and this is just totally like just a side point. If anything, there is a raise hand feature, and then like you can put participants, and then you can see who has a question because I know there's a lot of people. Yeah. So it might take a lot of work, but just an idea.
The answer is yes to everything. The problem is right now I'm looking at all you people, and I see who's there. I see a list of people, and I see the chat thing. As soon as I go to share the PowerPoints, I see the PowerPoints, but I can't see who's here. I can't see your screens, and I can't see the chat. So, I mean, what you just did, unmute and interrupt me and say, Professor, this is really important. I got to know something. Can you explain that? That's the only way I can tell her to do it. See what I mean? And I won't be insulted because I'm tired of talking the whole time. So just unmute and say, look, you said something brilliant, but I just don't understand that. Tell me what you meant by so-and-so, and I'll do it. I'm still learning how to do WebEx. And as I said, right now I can see chat. Right now I can see you. Right now I can see the list. When I start to share the PowerPoints, I'm not going to be able to see all those things, and that's the problem. All right? All right. Somebody said that sounds good. All right, now let me just do this again. You're all hearing me okay, though, I understand. Okay, good, because yes, okay, you're hearing me good. Yeah, because I've got a new microphone for this. Now, Microsoft PowerPoint. Okay, I got to do something. I'm going to close this PowerPoint. Just a minute. Just a minute. I'm going to close this PowerPoint. No, I'm going to close this PowerPoint. Now I think I should be able to. Where the hell is the? Okay, there we go. Are you seeing? Okay, are you seeing a PowerPoint?
Yeah.
Okay, whoever did this, that's great. All right. All right, so you're seeing a PowerPoint. Notice it says Guide to Networking Essentials. Notice it says 7th edition. Okay, that's why I wanted you to buy the book for the 7th edition. All right. And you're all hearing me. Okay, good. So what I'm going to do now is I'm going to start. I'd like to get rid of this. I'm going to start going through this. And no, you know what I'll do? I'll just go through it this way. All right, so we're doing 7th edition. All right, let's begin. You don't need any notes for this PowerPoint. This is just an overview of computer concepts. By the way, I have a little idiosyncrasy. I'll give you hints on what might be on a test. I'll give you hints on what you might want to take notes on, and I'll give you hints on what you don't need to worry about taking notes on. But I assume you're all seeing, anytime there's a problem, interrupt me. All right. So all they're saying is, I don't know what they're saying here. Screw it. Okay, now, here's the first thing. This is artificial. This is very easy. This would be on my first test. People actually get it wrong, but it's silly. You're breaking the computer's functions into 3 things: input, processing, and output. Pretty obvious. The microphone, that's an input. The camera, that's an input, right? The monitor you're looking at, that's an output. So it's pretty obvious what an input-output is, all right? If I ask you, which is an example of an input device, a microphone is an input device, a speaker is not. What's an example of an output device? A speaker is an output device, a microphone is not. What's a mouse? A mouse is an input device. What's a keyboard? A keyboard is an input device. Now, I got a good one. What's a scanner? Well, a scanner is an input device. What's a printer? Well, a printer is an output device. Believe it or not, people get that stuff wrong on the test. I don't know how, but they do. You are seeing the PowerPoints okay, right?
Yes. Yes.
Well, I want to know. All right. Yeah. Right. Okay. Okay. So I'm trying to get to the next one. Okay, good. So here it is. Input devices, keyboards, microphones, webcams, scanners. Know that for a test. And if it says multiple choice, which one of these is an input? Which one of these is an output? I mean, people get that stuff wrong. Holy mackerel. This is an interesting one, a CD or a DVD. That could be either one. So when you're watching a movie on a DVD, it's an input device. But if you're saving your term paper on a CD, that could be an output device. When you play your term paper back on a CD, now it's an input device. So a CD or a DVD could be an input or an output device. It's very easy stuff. Don't get it wrong on a test. Okay, here's the tricky one though. Input we know, output one. What's the processing? Well, the processing is the actual computer I have in front of me. What's in it? It's got a CPU, okay? It's the main processing component. It's got a microprocessor, central processing unit. It executes the instructions and it does the thing. So if I type in the word A, that's input. The word A is on my monitor, that's output. But the thing that makes it an A from input to output is the processing, okay? I mean, I shouldn't have to explain this thing, but people get this wrong on tests. Don't do it. Study it. Okay. Quick thing about the cores. It used to be if you wanted a multiple microprocessor, you had an old motherboard and have 3 or 4 CPUs on it. What they do today is they put several microprocessors in one chip. So I like when it says it was like a person with 2 brains. That's kind of silly, but one little chip has 2 or 3 or 4 microprocessors. That's what they mean. Plug it in and do the PowerPoint from the USB port, then it's an input device. But if I store my term paper on the USB port, then it's an output device. So a CD, DVD, or USB can be both an input or an output device. A monitor or printer is always an output device, and et cetera, et cetera. Scanner input device, printer output device. Just don't get them wrong on a test. Just hint, hint, that stuff could be on the first test. Right? I want to make sure I didn't skip anything. Yeah, right. We're now talking about storage on a computer. And the big thing, what's going to come to a few more slides, is this thing down here. The CD or the DVD is a long-term storage device. You put your term paper on it. You put a movie on it. The USB flash drive. Those are long-term storage. The short-term storage is the actual memory in the computer that runs the program. So when you're playing a video game, the thing that lets you play the video game, that's the working memory. Now, again, we're going to have 2 slides on this coming up, but know the difference between the two. And here's the first slide. This is important. Random access memory is the one that's built into the computer, okay? You run your program, you run Word, you run Excel, you run PowerPoint, you play a video game using the internal RAM on your computer. That is your short-term storage. It's also called working storage because that's what lets you do the stuff, okay? Big cuidado, the first thing here. When power's turned off, it's gone, volatile. When you turn your computer off, everything in RAM disappears. Not so if your hard drive, your USB port stays there. But when you turn off your power, everything in RAM disappears. So RAM is volatile. Turning off power, the RAM goes away. And it's called working storage, and it's short-term storage. Okay? Know that for a test. Now, here's a biggie. This is the other kind of storage. This is long-term. Look at the first dot. Even when there's no power. Now, what do we say for RAM? RAM, if you turn power off, you lose the data. With this one, if you turn power off, you keep it there. Why? You put something on your hard drive, and you go home for the night and turn everything off. The next day, you expect it to still be on your hard drive. And it is still on your hard drive. See what I mean? I see people join the meeting late. Welcome aboard, except that you're missing stuff. Okay, so there it is again, long-term storage, okay? You keep the data, it's your hard drive, your CD, or your DVD, or your flash drive. And what's the difference? if you lose power, everything stays on that, right? As opposed to this one here. But this one, when you lose power, you lose this stuff. And it's supposed to be that way. It's not a problem. Just understand that short-term storage is working storage and it's RAM, and that long-term storage is the CD or DVD, and it's used for storage. And that's the one that keeps data if you lose power. The other one loses data if you lose power. Now, again, I'm stopping for a minute. As brilliant as this lecture might be, you're not going to learn it from my brilliant lecture. You're going to learn it from reading it in the book, from downloading the PowerPoints, from underlining, from sitting there and trying to read it and trying to make it yours. Hopefully that's what you're going to do. Okay? And I can already tell half the class is going to do that, probably get certified and make a lot of money, and the other half will not and go nowhere, but I have no control over that. Okay? You study hard with this stuff, it's going to pay you big dividends, not me. All right, I'm going to keep going for a few more minutes. The class officially goes from 3:15 to I think about 4:30. Because it's our first day, I'll go a few more minutes and then we'll stop, because lecturing can be boring. Monday will be all lecture. The following Wednesday, we'll be doing maybe some questions at the end of the chapter and a half a lecture. But as we get into the course, I'll have to spend half the time reviewing for a test. I may have to spend half the time doing questions at the end of the chapter. So as we get into the course, it will be half lecture and half something else, okay? But it will be a full day every day, so try not to miss it. All right, let's keep going. And we don't get breaks in this class because this is it's a twice-a-week class. You don't get a break. Let's keep going. Now, this I shouldn't have to cover, but they want me to cover it, so I will. Ones and zeros, okay? You all know computers are ones and zeros. A binary digit is a bit. A bit is either a 0 or a 1. And you know how this came about? Computers are really switching devices. Original computers were just a massive bunches of switches. So if the switch is on, it's logic 1. If the switch is off, it's logic 0. A pulse can be 5 volts is on, 0 volts is off. So 5 volts is logic 1, 0 volts is logic 0. But if you're doing fiber optic cable, light on is logic 1, light off is logic 0. So I can send 1s and 0s to you over fiber optics by saying on, off, on, off, on, off. And I can send it through a cable, an RJ45 cable, by saying voltage on, voltage off, voltage on, voltage off. Now, this happens millions of times a second, but I can send 1s and 0s, and that's what I'm sending, okay? Understand that a byte is 8 bits. Understand that a bit is a binary digit, and a bit is a 1 or a 0. This you should know anyway, but if you don't, you have to know. All right? Anyone who thinks this chapter is a little too juvenile, this is an easy chapter. The other ones get a little harder. I don't know if that's good or bad. It's good because they're more interesting. It's bad because, oh my God. We're covering a question for somebody?
You have to cover that in the exam, the bits and the zeros, or just want to make sure?
Well, I'm missing the question. You have to know this stuff. I mean, I don't know. I don't know how the question is. This to me is stuff from 108 or from more basic class. However, and I assume you know it. If you don't know it, don't know it. That's all. That's all. All right.
And it's similar, kind of like the Morse code, right?
Actually, the Morse code is the original form of this, except it's a little da-da-da. This is just on or off, yes or no. But when you're talking digital, it's only it's never 1.5 or 1 3/4. It's always either fully on, fully off. That's the point. And that's how digital works. All right. I was going to say something, but I forgot it.
Also, just to clarify, so the data in a computer, I know this is pretty good. Data in a computer is represented in a collection of 8 bits, which is a byte.
B-Y-T-E byte. Yes, that's true.
Yeah, gotcha. Thank you.
Very good. Okay, this lecture is a little bit tricky. So whenever you see a thing like this, here's what it means. We're going to have a slide on the motherboard. We're going to have a slide on the hard drive. We're going to have a slide on RAM. And the trickiest one, I may stop after that, is that fourth one, BIOS-CMOS. And I used to write on the board for that one, and I can't, so I'm not sure how I'm going to explain that. But if I do a good job on that, then I'm teaching right. If I can't, then I'm not so hot. Now let's see how far we get with this. Now, that's a picture of a motherboard. Well, okay. That would be if you had a desktop computer. That would be what would be in the box of your desktop computer. Well, let's go over it a little bit to see what's here. This says they're RAM slots. What this means really is the following. These are slots where the random access memory would go. Now, what did we just cover RAM was? We said that RAM was those working storage things. You would put 2 RAM boards in here, and the RAM would be here. This is the CPU socket. In this socket would go a chip. That chip would be a microprocessor, central processing unit chip. It would fit in that socket. That's the motherboard, where the RAM and the CPU talk to each other. Now, let's try one more. This IDE connector. That would be a cable that would go to the hard drive. So the hard drive wouldn't go on the motherboard. The hard drive would be over here someplace, but a cable would be going from the motherboard to the hard drive. So what we got? We got the hard drive connected to the motherboard. We got the RAM connected to the motherboard, and we got the microprocessor connected to the motherboard. That means the computer can work because they're all connected together. These stupid slots here, expansion slots, this might be the sound card. This might be the network interface card. This might be a video card. See what I mean? These are where the cards would go. I would have shown this populated. I would have had the cards in there and had the chip is what links in the processing part, in the CPU part of the computer if it was a desktop. I'm not going to talk. You can read this slide. I generally leave it out. Now, this is important. A bus is not the vehicle you take to school. The bus is a collection of wires that connects things to it. And it takes the data from one place to the other inside the computer. So there's a bunch of wires inside the computer that's making data go back and forth. Now watch carefully. There's a trick to this one. It says there's a bus between the CPU and the RAM, CPU and the disk drive, CPU and expansion slots. Well, you know what? Bull feathers. Let's check here. That's what it says. CPU and RAM, CPU and disk drive, there's a bus between them. Let's go back here. Here's the CPU. Here's the RAM. There's a whole bunch of wires going between here and here. I don't see them. Here's the CPU. Here's the hard drive. There's a whole bunch of wires going between there. I don't see them. Well, here's the secret, Grandma and Grandpa and everybody. This motherboard is a multi-layered motherboard. Okay. And inside the motherboard are not actual wires, but sort of grooves or lands. So there's 8 or 16 pieces of metal going between here and here. How come you can't see it? It's buried inside the motherboard. There's a bunch of wires going from here to here. How come you can't see them? They're buried inside the motherboard. There's a bunch of wires going from here to here. How come you can't see them? Again, they're inside the motherboard. So let's go back to this slide one more time. What is a bus? It's a collection of wires that Natasha wants to annotate something. I don't care. All right. It's a bunch of wires that goes between one place and another. Okay. And that's what the bus is. And it's built into the motherboard. Okay. Now, there's one exception, though. The cable between the motherboard and the hard drive, that's a physical cable. That's also considered to be part of the bus. Bus is a bunch of wires connecting between places. Oh, I got a problem. How do I get out of this? Oh my God, how do I get out of this? Whoever asked me that, I'm screwed. Oh boy, I don't know what to do now. Yeah, I can make, that's fun, but how do I get out of it? Let's try something. I don't know what to do. Control Z, thank you. Am I out of it? I'm declining. You said Control Z. All Control Z does was give me the thing back, and then that doesn't let me. How about Control C? Wait, Control Z. How about Control C? How about Control something else? Beats me. All right. That removes the highlighter. How do I remove the annotation thing? Now let me try something. Wow, I can't even get into my. I was going to use my task manager. Let's try something. No, that's not going to help me. That's not going to help me at all. But I'm still in it. I still can't get out of it. There. Good, I did it. Okay, let's keep going. Now, we're ready. Sorry about that thing. We're going to talk about the hard drive. Well, what did we talk about the hard drive before? We said the hard drive was the long-term storage, right? And that's what it is. It consists of magnetic disks called platters, okay, that store the data in form of magnetic pulse. I'll come back to this slide in a minute. Yeah. This is a round disk. Now, they're talking about a platter. What it really is, it's a piece of plastic. But it's plastic and it's coated with something called iron oxide. Iron oxide is really just rust. You can't magnetize plastic, but you can magnetize iron. So if it's an iron-coated piece of plastic, what do you have? You have a 1 here, a 0 here, a 1 here, a 0 here. Well, how do you make that 1 and 0? A magnetic pulse. If there's a magnetized spot, that's a logic 1. If the spot next to it is not magnetized, that's a logic 0. If the spot next to that is magnetized, that's a logic 1. So what you do is you magnetize and not magnetize, and as the platter spins, you're reading 1 0 1 0 1 0 0 1 1 0 1 0 as the platter spins. When you play a record, the needle goes in the groove. When you play a platter, watch out carefully. This thing just floats on top of the platter. So in other words, the head goes on top of the platter and just finds the place and reads the 1 or 0. It still takes a little bit of time. Now, I mean, they measure the time in milliseconds, but the head has to move from place to place to get the data. So that's how a platter works. So let's try it one more time. Hard drive is long-term storage. It's a platter that stores in magnetic pulses. It's really a plastic platter, but it's been coated with iron oxide so it can be magnetized, and that's where you store things. So if I wrote a term paper and I want to store it till tomorrow, I put it on my hard drive. Okay? All these PowerPoints are stored on my hard drive. Biggie, the operating system is stored on my hard drive so that when I turn the computer on, it boots up into Windows. Where is Windows stored? On my hard drive. And again, there's the picture of the platter. This is for the more advanced people. Today we have these SSDs, and what they are is they're really solid state memories. You know what a USB drive is, a little thumb drive. They use the same thing as that is. So when I put my USB drive in my pocket, it keeps the data. Well, if I get a device that's really like a bunch of USB drives in a box, and I stick it in my computer, that's an SSD hard drive. It uses flash memory. The big deal is this one here. With the platter, the head has to move across to find it, okay? With this guy, you just go to this place in memory, you just go to this place in memory, you just go to this place in memory. So in other words, there's no moving parts. You can get from one file to another in microseconds, not milliseconds. Now, micro and millisecond sounds like I'm splitting hairs. But we're going from millionths of a second to thousands, from thousandths of a second to millionths of a second. The bottom line is SSD is considered long-term storage, but it's faster to get to. More expensive than a hard drive, but it's faster to get to it. What's happening is we're slowly transitioning. This is going away, and this is replacing it. Now, you can still buy computers with hard drives, but in the next few years, all computers will have this. Okay, but
and I'm guessing that the hard drives also they can break as well. Like, what if it stops spinning? Then it obviously won't work. So I guess the SSD, because there's no moving parts, that means there's less repair problems, I guess.
She's correct. It's less likely to break. Now, nothing is foolproof. Things do break, but it's less likely to break. Okay? Whoever wants to annotate shared content, I just decline. Okay? So it's less likely to break. She's correct about that. Know that an SSD and a hard drive are the same thing, except they're different. Well, say it differently. They do the same thing. They just do it differently. Again, I want to tell everybody this is a fairly easy lecture I'm doing, but a lot of this stuff could be on a test, input, output, difference between working storage and long-term storage. All of this could be on a test, is all I'm saying. It's not that hard, but you got to study it. Again, I'm going to stop the lecture in a few minutes, but we're getting to the hardest part of it in a few minutes. All right, so now. Well, random access memory is we already covered. That's the short-term storage. These are chips, okay? They go on the motherboard. There's no anything, and that is working storage. So look at the last one. If your computer runs too slowly and you put more RAM in, that will make it run a lot faster. If your computer runs too slowly and you put another hard drive in, that's not going to do anything other than make you store more stuff. So you need another hard drive if you're running out of storage space. You need more RAM if your computer's running slowly. See the difference? You want to speed up your computer, add RAM. If you want to have more storage space in your computer, add a bigger hard drive.
However, on the motherboard, you only see 2 spots for RAM. So what happens when you run out of RAM space?
That's that particular motherboard. You can get a denser thing, and in other motherboards, there are 4 or 8 spots for RAM. So you buy a better motherboard, it has more RAM capability, and then you put the RAM in. Okay? The motherboard I showed you is just one of them. Because we're in the 7th edition, it's a hopelessly old one. Modern motherboards have a lot more RAM than they can do. But again, RAM improves speed of the system. Hard drive does not. You see the difference? And we want to know this kind of stuff. Look, I know half the people in the class said, I know this code already. I'm really good with this. And this is silly, and I knew it. But I can tell that half the people in the class did not know this and should. Okay, now everybody's complaining. The lecture was too easy. Now it gets harder. Okay. What is the BIOS? It's called a basic input-output system. It's a set of instructions. It's a subroutine. It's a program that does something. What does it do? The most important thing. You come in the morning, you're exhausted, and you stagger over to the computer, okay? What is the first thing you do? You turn it the heck on. And when you turn it on, you punch a button, your computer turns on. What does it do? It magically comes up. It boots up. It says, here's Windows. What do you want to do next? Do you know that in 1980 or 1990, when you turned the computer on, it literally just turned on, set it to C prompt. And that's all you had to do. I mean, but you had nothing up there. You had no Windows. You had nothing going. Your computer boots up all by itself. Well, it doesn't boot up all by itself. It does it by the BIOS, a set of instructions that tells the computer to boot up. Now, I'm going to go 2 slides back and forth. This is what the BIOS does. Power is applied to the motherboard. The microprocessor starts out. And then the micro says, I've started up and I'm just sitting here. What the heck should I do? Well, there's 2 ways. You could type in what the heck you should do. You could say, okay, here's what you should do. I don't want to type it in. The computer should do it. So the computer then goes to the BIOS subroutine and says, I am now going to boot up the computer for you. And it says, step 1, do this. Step 2, do this. Step 3 does this. Somebody put that in and the computer boots up. POST, what is that? It's the power on self-test. It says, you know what? You think you got some RAM here. Let me buzz through all that RAM and make sure it's there. According to you, you've got a mouse here. Let me send a pulse to that mouse to see if it's there. Wait a minute. Your computer says there's a keyboard. Let me send a pulse to the keyboard to say it's there. I've got a custom microphone here. The BIOS says, let me send a pulse to make sure it's there. It tests everything. And then it does that. We're all set. The computer's working. Then the BIOS says, find out where the OS is. Now, what is the OS? It's the operating system. What's a better word for the OS? Windows. It says, this is a Windows machine. I'm going to load Windows for you. But first, I got to find it. Let me find Windows, and let me load Windows into RAM. Once I do that, your computer's booted up. But it wouldn't boot up if this BIOS subroutine wasn't there. Still not done with the lecture. Let's go back to this one. It's talking about the BIOS CMOS. This is where I wish I had the board, but I don't have it. I know I can annotate. When I annotate, I get in trouble. CMOS is called complementary metal oxide semiconductor. And what that is, it's a form of material. It's an alloy. And you buy a chip from the factory that's made of complementary metal oxide semiconductor. And that chip, you know what it has on it? Nothing. It's a blank chip. So you buy a chip, a big integrated circuit that has nothing on it, but it's made of complementary metal oxide semiconductor. Then what do? You insert it somewhere on your computer. I think it goes on the motherboard. There's a place where it goes. And then you put a program into the chip. Now, I got to be careful. Programs run in RAM. Most programs are stored on the hard drive. So the program is stored in the hard drive, but it runs in RAM. There's one more place a program can be stored. A program can be stored in a memory chip. And a CMOS is a memory chip. It's a chip that when you turn the power off, it keeps the program. So let's try it again. You go to a factory. You buy a complementary metal oxide semiconductor chip. It's blank. It's got nothing on it. You insert it into the motherboard. Then you program the chip with the BIOS. What is the BIOS? It's a set of instructions that boots up your computer. Now, here's where it gets tricky. They talk about the BIOS CMOS chip. This is the BIOS chip. It's a CMOS chip. It's made of complementary metal oxide semiconductor. And what it has on it is the program called the basic input-output system steps. So it's a chip made of metal oxide semiconductor that has on it a program called the basic input-output. And again, what does the basic input-output do? It does all these things. You apply power to the motherboard. You start up the CPU. Okay? You blah, blah, blah. Carry up the routines, whatever. And then it does the post test. And then once it's done, it says, I could be done, but I'm supposed to put Windows in. Let me go find Windows, and let me load Windows into RAM, and then I'm done. Now the BIOS is done. So let's do it one more time. The BIOS is the program. The CMOS is the chip. You put the program into the CMOS chip, you put it on the motherboard, and this is tricky. When you turn yes, whoever said that, they're technically the same thing, but the terms is what I'm after. The CMOS refers to what the chip is made of. The BIOS refers to what's on the chip. Are they the same chip? Yes. One refers to the material the chip is made of, and the other refers to what's on the chip. Here's what I'm after with this stuff. I'm going to stop in a minute, I think, 'cause I'm getting tired. This kind of detail, you say, well, it's the same thing. I don't have to know it. This is exactly the kind of detail that you have to know to get certified, to understand the stuff, to pass a job interview. See what I mean? People say, well, I knew they were the same thing, but I wasn't sure. Knowing it at this level is what they want in a job interview, and it's what they want on a real test. So there's your problem. So I would say of those 4 items, this and this together is the most difficult, and you would want to know that for my test. Okay? Now, I have a lot more to do, but I'm going to try something. Good. Okay, so now we're back to here. Okay. Class technically ends at 4:30. I'm kind of exhausted talking. I'll see how I'm going to do what I'm going to do next time. Again, 1 week is 2 meetings. So I have to get through this whole slideshow by Wednesday and Monday. I have to go through all chapter 2 slideshows by the following Wednesday, Monday. I have to go through chapter 3 slideshows by the following Wednesday, Monday. And I don't have a board to write on. I'll stick around, but was this useful? Did it make any sense? Could you follow it? Was it okay? This is what the course is going to be. I see people doing this, but this is how the course is going to run. It's this way. Do I think this is the best way to teach? No, but I also think it's not useless. I mean, you can learn this way if you buy the book and you study. So take that outline I gave you, try to order the 7th edition, go on tonight, do a Google search, try to find that Tom Show book, try to get it for 10, 20, 30 bucks instead of buying it completely new, although you can probably buy it for around $25, and try to have it within a week or two. And this is how I'm going to teach the course. Are you throwing tomatoes at me? Are you applauding? Is it okay? I'd rather be in school with you guys. I really would.
You did a good job. Thank you. Appreciate it.
All right. Anybody who wants to unmute and talk to me, you can, but we're done. 3:15 on Monday here at the same place. Okay?
Yeah. When do you think the class site will be up on Moodle?
Oh, yes. Good you reminded me. I forgot that we were doing it online this time. I generally start the class by Wednesday, Thursday, Friday. I mean, I'll have it done by Monday, absolutely. If it's not done by Monday, you can fire me. I mean, by this weekend, you should be able to do it. And again, the first week in Moodle, you'll see two things. No, you won't see the outline that I sent to you. You'll see all the PowerPoints. The PowerPoints you want to download is chapter 1, 2, and 3, because the first test is 1, 2, and 3. They're all there, but you won't need chapter 4, 5, and 6 until Halloween, and you won't need the other one until Thanksgiving, and you'll need chapter 1, 2, and 3 for the test at the end of the month. And it should be up within a day or two. Okay? I'm done, but I'll just sit here if anybody wants to say anything. You're welcome to leave, or you're welcome to ask me a question.
Professor, I have a question.
Go ahead.
So we also have class on Mondays too, right?
We have class, the class is Monday, Wednesday, and because we started late, started this way, it's Monday at 3:15 and Wednesday at 3:15 is when the class meets.
Okay, thank you.
Monday, Labor Day?
Monday at 3:15 and Wednesday at 3:15 is when the class meets, yes. The reason is it was supposed to originally be an in-person class, and at the last minute they converted over, so they said we're going to do it synchronous online. If we hadn't had the virus, you'd be trudging in and sitting with me in class. That's why they did it. I work at Bergen. I don't run the school. I didn't decide to go online. I didn't decide to make it synchronous. I didn't decide. I just do what they tell me.
Do we have class Monday? This is Labor Day.
Well, class is over. I'm just sitting here. Oh, Labor Day. Labor Day. No, there's no class. No. That's a good point. So this coming Monday, we will not do it. We'll do it Wednesday. I didn't think of that. That's true. I didn't think of that. Very good. Very good.
How we doing, Professor?
Yeah, we're off Monday because it's Labor Day. People seem to like it.